Okay, our lesson today is on problem solving, and this is going to be part 1. In this video, we're going to look at how to write systems from a word problem, focusing specifically on the writing of the system. And then part 2, we will actually go through and solve each of those word problems, or each of those systems for the word problems. Okay, so make sure you have your essential question written down. How do you write systems from a word problem? And then restart the video when you are ready. Okay, now previously we have written equations from word problems, but they were different because we only used one variable. But now we're using linear equations, and we can actually use 2 different variables. And so that actually makes this whole process 1,000 times easier. Okay? So as we look at these 4 word problems, I want you to think about, is the word problem giving us sentences that we can translate word for word? Is the word problem giving us totals, like total amounts, a total cost, a total amount of tickets, a total amount of nuts, or whatever you're going to see. And then also I want you to look for numbers that you can multiply the variables by, like a cost per pound, miles per hour, something like that. And as we go through this, the first thing we're going to do is define our variables. And again, the good news is we can use 2 different variables. We're going to write the equation, and then in part 2 of our video, we're going to solve it. Okay? So take a minute and read the first word problem to yourself. You don't need me to read it out loud. I do want to change some of these numbers because I realized it doesn't work for us. It would work for writing, but not for solving. So we're going to change that to 14, and we're going to change this number to 6. Okay, sorry about that. Okay, so what do we have here? Do we have a sentence to translate? Do we have any totals? What do we have? We do not have any totals. We know what Booker spent on tickets, and we know what Paula spent on tickets. And so we're basically going to use that information to write the equations. So it's almost the translating, number 1, translating word for word. So what are our variables going to represent? What 2 things is it that we don't know? And remember, your question here at the bottom is always going to be a clue in to what your variables represent. I hope you notice we don't know how many tickets. So we might say that X is the number of tickets, and Y is going to be the cost. And we are talking about the total cost. Okay? So let's look at Booker, and let's write an equation for Booker. So Booker's cost, Y, is going to be equal to 65 each, so 65 for each ticket, 65x, plus that one-time fee of $14. There's Booker. And then Paula, her total cost, it was $69 for each ticket, and plus that one-time fee of $6. So as simple as that. That's it. There's your system. Okay, let's look at number. Remember, we're going to come back and we're going to solve this later. So let's look at number 2. Number 2 is a little different. Read it to yourself, please. Pause the video if needed. So in this problem, let's see what we've got here. I noticed that it says if Gunther's investment rose a total of $684, so there's one total. So that's going to be equal to, one equation can be equal to $684. That is the total that the investments rose. Okay? And then we actually have another total, and it's this $10,000. That $10,000 tells us the total amount of money he invested to begin with. Okay? So if you remember back when we had totals, a lot of times this is when we were going to write our equations in standard form. Okay? So now what do our variables represent? What is x and what is y? What are the two unknowns? Let's look at our question. How much did he invest in each mutual fund? So right there, that tells us what our variables are going to be. X might be the amount in Fund 1, and Y would be the amount of dollars in Fund 2. Okay? So let's see. Let's start with the easy equation. We know he invested a total of $10,000. So Fund 1, X, plus Fund 2, Y, has to equal 10,000. And then our next equation is how much money it rose. And so that's where these percentages come in. Okay, we know it's rising by a percent of a number. So remember too, anytime we put percents into an equation, we do need to change those to decimals. Okay, so for Fund 1, how much did it rise? 0.06 times x. So see, that's where we're looking at where those numbers that we multiply by the variable, right there. Plus, for Fund 2, 0.09y. And that's it. There's your system. Simple as that. Okay, let's look at number 3. Everybody loves perimeter problems. Not really, right? But the good news is we can use two variables now. The question is specifically asking for what is the length of the rectangle. So I'm going to use L for length. We need to get used to using different variables. A lot of times the problems will tell you what variables to use. So you need to be comfortable using something else besides X and Y. And if we're talking about perimeter, we probably need to know what the width is. We probably don't know what that is. Okay, the perimeter of a rectangle is 72 inches. So that's like a total, right? And do you remember how we write perimeter of a rectangle? Think back. I'll draw a little picture here. If we've got the length and the width, remember it's 2 times the length plus 2 times the width. So there's one equation. And then notice in the second sentence, it says the length equals 6 inches greater than plus twice the width, 2 times the width. So the length is 6 plus 2w, or 2w plus 6, either way. And that's it. Okay, and then the last example. Read that one to yourself. Pause the video if you need to. So let's start with, I'm sorry, that's blurry. Let's start with the question. What were the prices for the gloves and hats? So boom, right there. That's your unknowns. So we might say that G equals the price of the gloves, and H represents the price of the hats. Now we have two people here. They each bought a different amount, and if you'll notice, we know for Cody what the total amount was that he spent. I keep moving and it keeps changing the blurriness. I apologize. And then Tori spent $30. So we have two totals. We have the total for Cody and the total for Tori. Okay? Now, what numbers are we going to multiply? We know we've got gloves plus our hats. Well, how many gloves did we buy? We bought 2 pairs. So 2 times the cost of the gloves plus 4 times the cost of the hats equals 43. And then for Tori, she bought 2 pairs of gloves, so 2 times G plus 2 halves. 2 times h. Boom. There's your system all done.